The last situations I want to talk about have to deal with asymptotes. So an asymptote is when I get really, really close to a value, but don't cross that value. So an asymptote happens in our class on a couple particular graphs. It can happen on exponentials, logs, or rational functions. But we aren't really going to get into logs right now. What I want you to recognize is that this first graph is exponential. And exponential always have a horizontal asymptote. It can really help if you can identify this parent function, which is why we started off the course with looking at parent functions. So if I look at my domain, the first thing I hit is this arrow going to the left. So it's going to the left to negative infinity. And I follow my graph, and I keep going, and I have this arrow that's going to the right to positive infinity. Now, as we start talking about graphs getting really close to values, a lot of people will want to say that that has a y value, or that domain is going to 1, and they want to end that with a 1 instead of a positive infinity. But what can help is to remember that domain is all your possible x values, aka what can I plug into this equation? And if my exponential function was something like 2 to the x, I can plug in whatever x value makes my heart happy. I can plug in 4, I can plug in 100, I can plug in 5 million. So I have no restrictions on my domain. Now let's look at the range. The range, the first thing I hit as I move from the bottom of my graph is an arrow going down, which means it's going to negative infinity. And now as I move up my graph, do you see how it levels off right there at 2? So it's leveling off, it's approaching 2, but it's never going to actually equal 2. So we're going to use a parentheses there. With an exponential function, the example I use is that if I imagine you have a cookie, and I keep splitting that cookie in half over and over and over again, those pieces, eventually you get crumbs, right? So no one would say, I had a cookie today if you ate a crumb. You had 0 cookie. But is it actually 0? No, there's still an infinitesimal, little teensy tiny bit of cookie there. So it's not that you're actually equaling, in this case, 2. It's that you're getting really, really, really close to 2. And if you can recognize it's an exponential function, it will always have a horizontal asymptote. The last example is a rational function. So what will help on this is if I sketch in any asymptotes I see. So this one, do you see how the left and right pieces are getting really close to that line? And then I have a vertical asymptote going on here at that x value. And I know that's happening because I can see both pieces of my graph are getting really close to that line. So I like to draw those asymptotes in first. So my domain, I start at the leftmost piece of my graph, and I don't have it drawn here, but we have an implied arrow going to the left forever. And as I move on my piece of my graph, I start getting really, really close to 2. I'm approaching 2, but I'm not exactly equaling it. So I have to put a parentheses. Union. I have that asymptote. Where is the asymptote? It's at 2. My next piece of my graph picks up really close to 2, but not exactly 2. And then it moves to the right forever. So to positive infinity. Basically, in an asymptote, you're going to have negative infinity, positive infinity, but in the middle, you'll have where your asymptote value is, which in this case is 2 for my vertical asymptote. Why is this happening algebraically? We'll get into in Unit 5. So we don't need to worry about why, math-wise, this is happening right now. So let's look at the range. So the range, when I go from the bottom to the top, I hit this arrow going down forever. So that's to negative infinity. And as I move up my piece, I keep going up, and I start leveling off at a y value of negative 3. It's an asymptote, so I put a union. My next piece starts where it's leveling off at negative 3, and then it goes up and up and up forever to positive infinity. Once again, because of these asymptotes, I really have a negative infinity, positive infinity range with this missing value in my range where my asymptote is at -3.